which is not, unfortunately. So we move over to the next presentation.
Again, that would be by Dr. Arsalan. Pressure control vein graft flashing results in superior histological quality, a randomized trial.
Dear Chairman, dear ladies and gentlemen, again, thank you for giving me the opportunity to talk here. And this time about pressure-controlled vein graft flushing and the results and the results of usage of this syringe. So the same I just showed you a couple of minutes ago. Why are we still talking about saphenous veins? As we all know, arteries are much better in terms of long-term patency. Again, the meta-analysis showing that REMA or the radial artery are definitely better compared to the saphenous veins. But this is real life. If you look here for the German numbers, we have the usage of vein grafts in about 78% of all CABG operations in the year 2011. So we really have to look after the saphenous veins. So why is the long-term patency so bad? There are different reasons for graft failure, for example, neointimal hyperplasia or thrombosis. And the question is it possible that the pressure distension could induce these damages? There's a lot of experimental literature regarding graft distension. Here's some studies here. The first one from 1976, looking for this and showing that in vitro pressure of 600 millimeters over mercury leads to histological damage. And again, 300 millimeters leads to endothelial damage, edema. Another one, contractile response, impaired relaxation, upregulation of endothelial adhesion molecules, and reduced endothelial nitric oxide synthase activity, and inflammation too. So 300 millimeters over mercury and more, is this really realistic? Is this what we really do while we are performing graft harvesting? What we did is just taking a piece of the saphenous vein that we didn't need for bypass grafting and then connected it to the heart-lung machine and just tried, okay, how much pressure are we really how much pressure is there really in the vein graft? And unfortunately, the heart-lung machine could only show 500 millimeters over mercury, so I can't show you the real numbers, but it's definitely too much what we are doing, too much pressure. So easily surpassed during standard flushing. How can we avoid this? There's a pressure controlling syringe from Maquet. Here you can choose between 150 millimeters over mercury, 250 and 350. We use the syringe with 250 millimeters over mercury. Now again checked, does the syringe really work? And here it shows it's hard to get over 200 millimeters over mercury. If you press harder, just the liquid goes here out of the syringe. So not possible to get over on this pressure. So yes, it works. Now the question is, does the usage of the syringe really preserve graft quality? What we did was a randomized trial with 50 patients. Either the usage of the pressure-limited syringe or a conventional syringe and vein remnants were examined for graft injuries using CD31, immunostaining, and eNOS Western blot analysis. So here are the results for the CD31 staining. Here we see the endothelial integrity intact in the pressure-controlled syringe, and here a lot of gaps in the conventional syringe group. And this was significantly different, so significantly higher endothelial integrity in the pressure-limited syringe group. Here we look for endothelial nitric oxide synthase activity, and here we again saw a higher rate in the pressure-controlled syringe group compared to the conventional syringe group. And we performed a Western blot 2 to look for this, and again here we have a higher expression in the pressure-limited syringe group. In conclusion, using a pressure-limited syringe reduces endothelial damage. The usage of a pressure-limited syringe preserves nitric oxide synthase, and apart from the additional costs, there seems to be no downsides in using the system, and it might lead to better vein graft patency. Thank you. you.